And so we can actually, reduce the number of people and GDP at risk. If we combine domestic and industrial productivity, we get a much bigger impact. And obviously, if we also make changes in irrigation efficiency, which we implement as changes in basin efficiency, we also get an impact. However, this impact looks very small, and in reality, the impact could be much larger. But the way we are modeling the various sectors, so we first we give priority water right to the domestic and industrial sector. So if we increase efficiency, that's it, we save really water. But in irrigation, if we actually increase efficiency, the water can be reused. So if we become more productive, and if there's water scarcity, they'll use the water. So that's why the efficiency improvement in irrigation, it's not physical water safe. It's water that can be used again in irrigation if there is crop water demand. So this is why we should actually not show the graph like that, because it gives the impression that the irrigation water savings are very low. But in this case, we are allowed the use of safe water in irrigation. We don't allow it in domestic and industrial. So, but anyway, all sectors can make a difference. And this just summarizes the results one more time. So, as we knew, and there are other studies out there that show that significant, part of the current population, 2.5 billion people, live in water-scarce regions as defined. 22% of the global GDP, 39% of global grain production is located in these areas. Under business as usual, those values will all worsen, and so there is really, I guess, a motivation or a justification for doing more than we're doing today. And China and India, because they are the largest food producers, but not only, they're the largest everything. So, it's important to pay specific attention there, and they will really materially risk growth. And there's other research out there where the Chinese do once in a while calculate how much growth was affected by water scarcity, like in the Delaware Basin, etc. Low-income countries will obviously be more strongly affected because they grow faster. And their infrastructure is not very well developed. They tend to be in the semi-arid areas. But also, very well-developed regions such as California obviously, face growing water scarcity very rapidly. And then if we look at these alternative scenarios, under a gray water world, we obviously would increase both the number of people living in water-scarce areas and the GDP, which they can call at risk. And as a result of water scarcity, on the other hand, very high levels of water productivity improvement can really move people out of that water-scarce area. Again, both developed and developing countries can benefit from that, and some regions, such as India, productivity improvements help, but they're definitely not sufficient they will stay in that very water-scarce area. And this is before we look at, for example, extreme events, climate extreme events, which, especially for India and some other countries, will be more important than for most developed countries. So basically, and then looking at the question of does water productivity improvement support additional economic growth? So basically, if we compare the various scenarios, we can say that only the blue world has the same type of water scarcity exposure as the business as usual. You can have a higher economic growth rate under blue to achieve the same water scarcity that you have under BAU. So that's kind of the way we're trying to address that question. So you can have higher growth with the same scarcity under the blue scenario compared to the BAU scenario. And that's the end of the presentation.
Well, thank you very much, Claudia. I'm sure there will be questions. Your presentation has raised curiosity. while colleagues reflect, let me ask you one. Well, with efficiency, yes?
Yeah, it should be tap water.
You know, I think, as I understood your talk, the cost of growth foregone would be the opportunity cost for mismanaging the water sector. But did you also figure out directly what does blue water cost?
No, we didn't go into that. But I would think that at least for the water industry, that they probably have some idea, and we did try some approximations for the irrigation sector, but it's very difficult because you have so many ways of affecting efficiency, obviously in all the sectors. So one, technology, you could convert everything to sprinklers and drip. So that's one way to approximate the cost, but the real cost, of course, could be quite different. In the domestic and industry sectors, they seem to focus very much on technology, because technology can really do a lot. And technology has done a lot, especially in the industrial sector. I mean, the reuse recycling rates, they're incredible that they're achieving today. So, yeah, I think it could be done with somewhat more precision in the industry and domestic compared to the irrigation sector, but no, we haven't done it. But on the other hand, so what is the cost of higher food prices? Is it only increased malnutrition, or what is the cost of that? Yeah, so that's also difficult to calculate. What is the cost of not increasing productivity?
Okay. Well, let's listen to more questions or comments, please.
Thank you very much. When you indicated industrial water use, does it include water use in energy sector, cooling water, and?
Yeah. So in fact, we used to have only one industrial water demand sector. Then we disaggregated it to three. So the manufacturing, cooling, and the agro industries, and now we're adding it back into just two sectors.
This was Professor Bogardi. As we are live streaming, please say your name so that people in the camera get to know you. You wanted to follow up.
Still would like to continue on the energy nexus. Do you see in the blue world a role for hydropower? And if yes, what type of role?
Okay. Yeah, I mean, let me try to think about that. So there was, so they just used the so-called new policy scenario of IAE. So we would, I don't know exactly what's in that scenario, but what we did find is that whenever we increase energy efficiency, we kind of reduce water use efficiency somewhat. So in the blue scenario, they did use, I believe, the so-called new policy scenario, but said that we are not producing bioenergy from the first generation technologies, but we only produce waste. We only use some waste areas that don't consume any water. So in terms of hydropower, I would have to refer you back to the IAE report that you might know better than me. So could look it up for you.
Yes, please.
Yeah, good decline. At the end, you came to some comparison where you used the term advanced regions, how they cope with water scarcity. Maybe it sounds a bit old-fashioned. You are now taking California as an example for failing to cope with water scarcity over the last 40 years. And I wonder why we don't use the example, my favorite case, the Ruhrgebiet, or a case with 100 years of experience how to cope with water scarcity. And again, also in this presentation, I missed the aspect of the value created by a long-term sustainable mechanism, whatever critical areas are attached to that, to manage over decades a water management system for energy, industry, agriculture, and specifically high quality domestic water supply at extremely low prices. And that's exactly the point. Where are the trade-offs when we look into such a process? So I wonder why you don't put on your scale success stories, and there are more, not just the Ruhrgebiet, but I think it's one of the
So you're saying that in the Ruhrgebiet the domestic water use prices are extremely low?
Yes.
So how high?
Extremely high water efficiency and provided with 0.4% of the average income. There are not many places in the world that cope with that.
Yeah. But anyway, generally, globally, when we talk about domestic water fees, Germany is rather on the higher side and not on the lower side. But it's, I guess.
What do you mean? Water scarcity?
No, the domestic water charge. This is in Germany.
So the higher side?
Yeah.
That may.
Very high.
It's about 3 times in Washington DC, if I may interject.
And Montreal,
what I pay
we have
in
no
bond.
meters. So we have
But the quality may be better. I like
So
the
there may
bond
be
water.
quality.
But nevertheless,
anyway,
my willingness to pay is not constrained. But this was a serious question.
Yeah, the real issue, I mean, so I'd say, actually this slide definitely didn't say that California was a failure. It just says that, California is a developed region and one of the largest economies, and it obviously, has to cope with growing water scarcity, which means, additional investments in water supply. They already have this canal, delivering water from north to south. At the same time, they're irrigating rice. So from that point of view, yes, it's a little bit of a failure in terms of water management. It's based on, historic, same thing, long-term history of why farmers have water use rights, etc. And why they're not willing to sell them for a high price at this point. Yet, in terms of regional disaggregation, our modeling framework, we don't have a lot of disaggregation for Europe because we are focusing on developing countries, and we did disaggregate the major river basins and units in China, India, and the United States because they are the largest food producers, the 3 countries, the largest grain producers. So, we chose that example because for the audience in Veolia, North America, that was the most useful. They might be involved in the Ruhrgebiet water services as well, and then maybe they would be interested. But this is just, we used that case because it was of interest to the client. But I also agree with you, if you already have achieved very high water use efficiency levels, and in the case like Germany, because of regulation and other reasons, you have very high efficiency levels. Even so, water scarcity is not very high compared to other countries that have not achieved similarly high efficiency values. So they still have a way to go. So it's difficult to factor that in, but that's reality.
Okay, next please.
Sorry. No, didn't see you. Go ahead.
Oh, thank you. Alejandro Guarin. I work at the German Development Institute. I have, if I recall your graph about the relationship between water scarcity and growth, and it seemed that there was not a very particularly clear relationship, and if anything, the countries that are growing the most seem to be the most water scarce. So my question is, do you think it is this emphasis, which was, I assume, presented to you on the relationship between water, productivity, and growth, do you think this is a warranted key research question? And so why that sort of why that graph, and what sort of relationship do you see? And kind of follow up on that is, if you had all the money in the world to do your own thing, what would be the kind of key research question related to water productivity? If it is
to water productivity.
Yeah, if it is not this relationship to growth.
Mm-hmm. Okay, so it's correct that because the OECD countries they don't grow very much, but that the reason is not because it's not necessarily water related. It's actually very likely not water related that they don't grow that fast. It's just simply